Hello, my name is Ramona Pelich. I'm working at the Luxembourg Institute of Science and Technology, and today I will show you the different applications we have implemented in the WASDI platform for our flood mapping algorithm named HASARD. So I will start with the first application that aims to map floods using two Sentinel-1 images. And for this, I will show you firstly, for example, how to explore catalog or the Sentinel-1 catalog in the WASDI platform. So for this, we will have to go in a workspace. Probably you're already familiar with using the WASDI workspaces. So I will just go and open one of the workspaces. For example, this one. And here I have already downloaded some images so that we don't wait now for the demo for processing the images in real time. But I will just show you, for example, how to search flood images in the catalog and how to choose them and add them to the workspace. So you have to go here in the search tool, and for this demo, I will focus on a flood event that occurred in Japan in October 2019. So we will move on the map and choose the area in Japan. So for selecting the area of interest, for example, you either draw a bounding box manually on the map, or you can also, for example, enter the coordinates. So in this case, let's draw the area of interest. And the date of the flood, I said it was in 2019 October. It was 12th of October. So we select here in the filters the dates of interest, and then we also have to select the characteristics of the Sentinel-1 product. So for this application, we are interested in the GRD images. That's the intensity or amplitude images, and the mode of the Sentinel-1 sensor is interferometric white spot. So now we have chosen the AOI, the dates, and the characteristics of the Sentinel-1 image, and we can run the search. So as you can see here, we have different images, but it is important for this application to focus on the same orbit of the Sentinel-1 sensor. So in this case, we are going to focus on orbit number 46, and we have to enter this also in the filter option. We will have only one image corresponding to the flood event. So this is the image corresponding to the flood event, and we can already add it to the workspace. So here I have different workspaces, but we go and select the workspace of interest, and then we can click to add this product to the workspace. And as I said, it's an on-demand application which requires two images, one acquired during the flood and one acquired before the flood, because it's a change detection methodology. So for this, we have to go in the time filter and also choose an image that was acquired before the flood. So then we can select maybe a period of, let's say, 2 weeks before the flood event, and we run again the search. And then we should have different images from the same orbit that can be used as reference images for our algorithm. So for example, in our case, we can use this image acquired on the 6th of October. And again, we can also add it to the workspace here. And that was all to show you how to search and add the images in a WASDI workspace. And then to run the HASARD on-demand application using two images, we have to go again to the App Store in the flood category. And for example, here, if we type HASARD, we will have HASARD on demand, and we can run directly the application from the App Store. It's free, so you can choose this option, open application. And then here we can open a workspace that we have already created. So here I will open the workspace that I created where I already imported the images. For example, this one. And then here in the list, I should already see the images that are present in in this workspace, and I can select them for my application. So here I have a list of all the images that are present. In our case, we have to choose as reference the image that was acquired before the flood event, so it's the image on the 6th of October, and then the post-event image, so the flood corresponding image. It's the image on the 12th of October 2019. And we have here also for advanced users some parameters that are related to the flood mapping algorithm itself. For example, the algorithm that we have is based on a hierarchical split-based approach. So here we can choose the number of levels in which we want to split the image. Then also we have some coefficients that are related to the statistical parameters that we extract from the images to derive the change detection parameters, and then also to estimate the distributions and the flood extent. I will not go now in all the details, but these are advanced parameters that, for example, if you will look at our published scientific papers, you will understand exactly what their meaning and how to parameterize them. But the default parameter should work for all general flood events. So now we have all the elements fixed here, and we just have to run the application. And then we have to, in order to analyze the results, we will have to go back to the workspace. I'll go back to the same workspace where I already got the flood results. So we'll open it. And for example, here I have different files, and these are the final flood map that I obtained for these two images. So if I click on the product, on the result, on the flood map, for example, I have here bands. So here we have the flood map that we have obtained, and if we click on the band of the final result, we will have it directly overlaid in a WebGIS interface, where if we can zoom, we can see the flood that has been detected by applying the HASARD algorithm. So that's the main result of the algorithm. It is a GeoTIFF image that you can directly visualize it here, or if you want, you can also download it and use it on your own PC. Now I will show you also a second application of the HASARD service in WASDI. So it's the flood archive generator that has as purpose to generate daily flood maps for a given AOI that we select in the WASDI interface, and for a given period of time. So in order to show you how to run and use this application, for example, here you have to select an AOI. We will select again the same area of interest for the same flood event in Japan. So we select our AOI on the map on which we want to have the results, and then if we want, for example, we can select the start date and the end date of generating the flood archive. So we can use a date like 1 month or 2 months before the flood event, in case the flood was ongoing for a long period. But if the flood was ongoing for a shorter period, we can also select a couple of days before the flood event. So for example, here we can select 1st of October, and then we can also select some dates post the flood event. We can, for example, select for 1 month, and then we have, if we want, we can also add reference code to have the same name for the different files that will be generated. So here, for example, I can put Japan. The date will automatically be generated from the dates of the acquired Sentinel-1 files. So here it's a very simple application. We have to select the start and the end date of on which we want to generate the flood archive. We have to select the AOI, and then if we run this application, we can either run it in a new workspace, or we can open an existing workspace. For example, we can call it, we can use one of the already created workspaces for the flood archive, and we just have to run it, and then we will get a series of flood maps that are generated for all the dates that we have chosen in this time period. And then if we want, we can also put here, for example, the name, the number of the orbit in order to run it for one specific orbit on the Sentinel-1 sensor, and we run it. And now I will show you an example of how the results of this application are looking like. So for example, here, if we go in a flood archive that we have generated for the same flood event, you will see that, for example, here we have all the flood maps that could have been generated during the month of October in 2019. So if we start with the date of the flood, for example, was 12th of October, we can see here that we have the flood map that was occurring on the 12th of October. And for example, then if we click on the next flood map that was delineated for the 13th of October, and we display it, we will see that the flood is receding, and maybe we have more flood in different other areas. And then if we go on a later on date, for example, 18th of October, we have to uncheck this one, we can see that the flood is decreasing in the areas where we had the flood present before, because this was an event that lasted for just 2-3 days. But if you have floods like in other countries in Southeast Asia that are lasting for large time periods, for example, you will have the flood events for each day, and you will see how the flood is evolving, decreasing, or expanding in different areas. So that was all for the flood archive generator. And now I will show you the third application that is provided by our HASARD service. So the aim of this application is to automatically detect floods in urban areas by making use also of Sentinel-1 images. So for running this application, I will show you what you have to do in WASDI. So as you've seen already for the previous applications, we have to select, of course, the date of the flood event. So we will choose the same date that we have chosen for the same for the other application. So it was 12th of October. Here we can give a name of our area of interest. Then we have to select the bounding box or the AOI in which we are interested. Okay, and then of course we also have to select the orbit. It is very important for this application to fix the orbit of the Sentinel-1 sensor. And here you have different parameters that you can choose because this algorithm, it makes use not only of the Sentinel-1 intensity or JRD images, but it's actually focused on using the multitemporal INSAR coherence of the Sentinel-1 sensor. And in order to delineate the INSAR coherence, we have to use the single-look complex SAR images. And for our algorithm, just to explain you briefly how it works, we use a coherence image that is derived for a pair of images acquired before and during the flood event. And then we also have a pair of images that were acquired only before the event. And then we can check the differences in the Sentinel-1 coherence images in order to understand where the flood was occurring. And this also we have to intersect it with an urban area map that has also been delineated from the Sentinel-1 images archive. So here are some parameterizations about how to use these images, how far we can go back in time. And yes, it's a little bit more complex, but here are the by default parameters that are generally working for all the Sentinel-1 images. And we also have the option here to run the application in a new workspace or in an existing workspace that we already had created in the WASDI platform. So for example, here I will choose an existing workspace. Then we run the application. And again, to check the results, we have to go in the workspace of WASDI. We open the workspace where we have run our application, our HASARD application. And then here we will have the different results. So these are the results that we obtain after running the HASARD flood mapping algorithm in urban areas. So for example, here, for this case, we have different maps that were generated. And for example, I will show you here the building map that has been derived for this application. Here, for example, if you want, you can also change the background source of imagery. So here, for this example, if we use this type of background, we can clearly see the urban areas that have been delineated by our algorithm. And then when we applied the urban flood mapping algorithm that makes use of the coherence images that I mentioned you before, we can also display the flood map in the urban area. So here, for example, if you zoom in, you can see depicted in blue all the areas that have been affected by the flood in the region of this city here in Japan. So these are the results of the flood mapping that are also automatically generated.